Thank you for coming to this session. So I think it's the third one we have today as Veritas. Hey, Peter, welcome back.
Thank you.
Good to see you here. You have any question? Peter is here. Okay. Perfect. Well, I'm lucky now here. I have Peter. I have Rakesh, Senior Manager for Engineering. So yeah, any question you have, he's here. So just a thing. So Rakesh is flying from Pune, from India. He's flying from Oslo. Well, you was somewhere else yesterday.
Dublin.
I coming from Madrid in Spain. So coming from different places, right? To really talk. We're very excited about HyperScale for OpenStack and what we're building. And I think it was a great day, at least for me. So I'm super happy, right? All the things I've been listening when we was in the panel today and talking about what you need. Yeah, data protection, backup, and quality of services. I was like, I'm not a salesperson, but I was like, stand up and say, hey, here we are. That's perfect. Yeah, but that's the reason I build products and I do not sell, right? But it's interesting. So the way we did is we had the keynote. We had another session talking about the quality of service. Now we're going to talk about data protection. Okay, and that's aligned with the architecture and with the value prop that we have. So just a quick reminder of what we saw this morning. Remember HyperScale for OpenStack, so we define storage based on hardware of your choice. I got that question this morning during lunch, is that it is not hardware I'm going to sell you. You buy the hardware that you want. This is really software. Okay, so you build it as you want. Compute plane, what do we have in the compute plane is the storage quality of service. Okay, where we have our algorithms that Rakesh gave a lot of detail in the other session of what we're doing there, how we implement quality of service, read cache, write cache, and so on. That's where we have our instances running with the full copy in your compute plane, getting the storage capabilities of the compute plane. That is the I/O that you need now that your application is running, okay, which is also protected because we got this resiliency with reflection, which is the deltas. So every write you make is resilient according to your policies that you define in your flavors. Okay, and so we keep that full copy plus the deltas. And then what we have is this data plane that really is a perfect thing also into the economics of the solution. Because what that means is that your second copy, your third copy, according to your flavors, are going to be to the data plane. The data plane is cheaper and deeper storage. Okay. What we get there is that every 50 minutes, we get those deltas, copy the deltas down, and generate a new point-in-time copy. Okay. But it's not only that, it's that point-in-time copy allows me to do data management or data protection, and allows me to do it from the data plane. What that means is that if you think in the I/O path, and how is that happening, the application is, can use this, is right in here. Right? My backup is reading from here. So you don't have noisy neighbors. The backup itself can be a noisy neighbor, right? Because sometimes you have to go here, read, and then here you have one instance fighting with another one, and then it's a mess. All the reads are coming from here. Okay? So that's one of the key elements, and we're going to be talking about that more in detail. So this allows you zero backup window, backup as a service, integration with net backup, and also we got the REST API, so you have any other solution, you can use APIs and get all the benefits from the data plane itself. So I talk about this a little bit. Yeah?
You also said in the presentation this morning that you had application.
Yeah, and we're going to be talking about that.
Okay.
Rakesh is going to provide a lot of details, and you're going to see a demo of how it works. Okay? So a little bit of what we do, because as I said, HyperScale is very unique. It's not just another CNET driver. Okay, it's really co-engineering with OpenStack and the different components where we have to have some touch points. And if you take a look to all the plugins that we have created and the check-ins into the open source, you will see that. Right? So with the do charms, we have 6 that you can just go and install, and with auto dependencies and so on. The same thing coming with O for the next version. So we have the volume extension that is running on the data plane. We have a volume extension on the Nova that allows all the filtering and the decision and intelligence about where to place, where are going to be my deltas. All that is taken for you. We have the integration with Horizon, as you saw this morning, all the visibility of what's happening with the storage into Horizon. We have the collectors, Stilometer, and so on. So really integrated solution, very unique. It's not just a storage solution that we try to attach to HyperScale. It's something that we build from the grown up with HyperScale, and now also with containers and Docker and Kubernetes, because we have the same solution for them. Okay, but built for the grown up with this kind of solutions. Okay. So the data management at the data plane, we get this 50 minutes point-in-time copies that it's happening by default. So it's not something you have to enable. That's happening. Because also, and we're not talking today about that, it's all the resiliency, right? So it's another key component is that because the deltas and the writes you have to compute, and because the point-in-time copy, if anything crashes, you have all your writes. And this is happening automatically. I'm going to generate a new volume for you from the first second. You're going to start reading from that volume.
But this is done real time, or can you lose 50 minutes of data?
You're never going to do any data. The 50 minutes, according to your deltas, every delta is going to be reflected in a synchronous way. And what that means is that when server crashes, my delta is already on another server. So I have my deltas plus my last point-in-time copy. It is like live migration. We do live migration. So we enable live migration with direct attached storage. It's on the same way. I have my writes going, I do my reflection, I move my workload, and I get my deltas plus my point-in-time copy. And it's one of the benefits is being locality, right? If you compare with things like Ceph, when at the end you add another storage, and then you have to rebalance everything, here you have compute. You add another compute, that compute is coming with local storage, you start running workloads there. Nothing happening in the rest of the storage.
But your recovery point objective is 0.
Yes,
Yes.
0.
Okay.
But also that's according to your policies. You can have you can create an instance with reflection factor 0 because I don't care.
Yeah.
Or another one with 3 because I want to survive 2 failures of the compute.
But yeah, how you present it, it looks like recovery point objective 15 minutes.
Okay.
But then you get the deltas in the compute now.
Yeah, you have to go back to the original architecture with the reflection and the compute plane and the data plane, and think of them as working together.
Yeah.
And the fact that this is a holistic solution, yeah, we introduced the data plane to store those point-in-time synthetic copies for the full, but one reflection target, and your latest point-in-time copy on the data plane will always be equal to your full copy.
Mm-hmm.
The other key thing is, in the case of a storage resource failure in your compute plane, you keep on running the instance wherever it is. It just keeps running. It's just using the storage now somewhere else. Right?
Good. You are hijacking my presentation. Thank you. Good. So that means 0 impact backup for OpenStack because all the reads are coming from the data plane. We do nothing with the compute plane. Well, we do just copy the deltas. So a backup is coming, and you get, give me the last 7 minutes deltas. Generate a new point-in-time copy, and then run a backup from that one. And as I said, this integrates with Veritas 360 data management. One of the key things is the integration with net backup we're going to see today. So what is the role of the data plane? Okay, again, this is a full integrated thing, but let's take a look to what the data plane is doing. So the mission for the data plane is get what we call the EDS, which is episodic data sync. That's generating the point-in-time copies from the deltas. It is also used for re-rotation. So this may happen when something crashes, a compute crash, you have to re-rotate data somewhere else. But you just have to move the data, not to give a massage to your whole storage. Okay, so just the data. Or you're doing a live migration. Okay, we use that too. And then we have 2 components here. One is something we call external storage provider. This can be anything. It can be a virtual machine, can be something, whatever you want. So you go to the UI, enable, and then we push all the binaries, all the stuff that we need. And then when you take a snapshot, you can take a snapshot and move that snapshot to the external storage provider. And you move data around. One of the external storage providers can be net backup. Okay? And we want to see that. So the episodic data sync happening every 15 minutes. You take a copy, you get that bit of all, you go to the UI, you're going to see all those snapshots. You're going to see the snapshots you can take anytime you want. So anytime you can make an API, right-click, whatever, take a snapshot, or this happening by default, that you can use at any time. Just make a click on there and decide what you want to do with that snapshot. Okay? So how it really works, you have the admin piece. To install a net backup, we just need what we call net backup media server. We're just going to move the data. One-click registration from HyperScale to net backup master server, so they know each other. And then assign the policies. You create policies in the net backup. The policy really tells you how often you want to run the backup, what is the retention policy, and things like that. Okay? And then you assign that and say, okay, when this policy is coming, I want to back up my Cassandra flavor, or my Gold flavor, or any instance with the name productions, or anything which is active. You make your rules, okay? Create those rules. And then from that point in time, the user is just automatically protected. And from the user point of view, the user can go and select, see my backups, make one click, and do the restore. So let's take a look to how it works. I will guide you through the demo. You will see quickly how it works. So this is the UI. You go to the backup export. You say this is a net backup. You put the name of the net backup media server or the IP. You put your password. So this is one-time operation. It's when you have to register with net backup. You do the registration. This is pushing all the binaries that are needed to that media server. Okay? So now they can talk each other. You got that registration with the media server. And now what you do is go to Net Backup Console. If you are not familiar with that, it's a very, easy one where you create your policies. You define a new policy. Here you define when you want to run the policy, what is the retention, how long time you want to keep your data, and so on. So you create a policy. Again, you can create as many as you want. You may have different kind of workloads running. You create all of them. When it's created, you go back to HyperScale. You're going to see every policy there. And what you do is to define the policy actions. When NetBackup execute that policy, what are you going to do? Okay, so here I have a instance called backup instance. I'm going to use as one example with the filter for the name. I go to the backup policies. I'm going to say assign update. Here you create the query. The query can be name equal whatever, flavor equal this, status active, inactive. You run the query, say, yeah, right now I got this one. I assign the policy and I close it. So now it's registered. Every time this backup is coming with that schedule at that policy name, the data node is going to run the query and it's going to decide what needs to be protected. So I run a full backup now. I have the visibility in these funny things, the net backup activity monitor. You see the green one which is running, right? I go to my task in the horizon. I can see the backups. It's been created. It's been running there. So I have the visibility from horizon itself of my backup activity. And if I go my backups, I have my list there. I can make a click and restore. This list is coming from net backup. So when you click there, we query the net backup master server. So say, what backups do you have for me? We get the list. You make a click, give the name of the instance or the new instance you want to create, click on restore. This is going to talk to the net backup. It's going to identify the data for you, move it back to the data plane, okay, and bring it up again. Again, what's going to happen? You copy that to the data plane, then reiterate to the compute plane and trigger the instance. So you can see the restore is complete, is done, and if you go to Horizon, you also will be able to see that your instance is there up and running. So now it's creating, reiterated, it's complete, and the instance will be restore backup instance. So just one-click operations to restore. Okay. So let's go with Rakesh into the details of how this really works, and then we're going to test the application consistent.
So the backup contains the deltas from the compute plane and
Yes and no. So yes, because when you take a backup, you generate a snapshot. So at that point in time, you get the last deltas and generate the point in time copy.
yeah, okay.
And that is what we backup. So yes, contain the deltas, but it's not two different pieces. Every time you take a snapshot, we go to the compute plane and we ask, give me the last deltas since the last whatever minutes.
Okay.
And then generate a new point in time copy, and that's what you move. And it's not only the data, it's also the metadata. Okay? So it's not just the data, it's all the things around the instance. So everything you need to bring that instance back again. Okay? So that's also an important thing. So how the magic works.
Thank you, Carlos. May I have
And you need a microphone. By the way, everything you said is not recorded because you didn't have the microphone.
It probably wasn't important anyway.
Okay, so I'm going to kind of in detail answer the same question there. So, okay, how do we make sure that whatever we have, we backed up, it's the consistent, application consistent, plus the complete, right? So everything starts either from Horizon or from the API. So as Carlos mentioned, that we do have APIs which you can write your own client, use those HTTPS-based REST APIs to take the backup. So the first thing which happens is the create snapshot. Now whenever we are taking a snapshot of a volume in OpenStack environment, the command goes to Cinder. Cinder is the storage driver. Since HyperScale, and what Cinder does is, Cinder creates the snapshot of that volume, makes the database entry so that it can associate the snapshot with the volume. So whenever the next query comes, it knows that okay, this snapshot is created for which volume. Since HyperScale also has its own Cinder driver, when you install HyperScale in OpenStack, we give you a volume type which is HyperScale volume, right? So we have a Cinder driver, and whenever a snapshot request is coming to Cinder, we get that notification in our Cinder driver. Now we know that okay, this is our volume and which VM is using this volume. We also know that okay, this VM is hosted on this particular compute. So you can have multiple computes in your environment. We know that the compute. Now just to answer this command, we send it to the compute node, and that is where HyperScale component sitting and interacting with the Nova node going to talk to the QEMU guest agent which is installed inside the virtual machine. And that QEMU guest agent is going to talk to the application, make sure that we have the consistent snapshot taken, application consistent snapshot taken for that particular data or for that particular virtual machine. We are going to see a demo later on in this slide. Once we know that okay, an epoch is marked and a snapshot is marked for the data, we take that data to the data plane using our EDS method, episodic data sync, which we have seen in point in time. So point in time copy is automatic, which happens after every 15 minutes. EDS will also get triggered even whenever customer has invoked the snapshot command. So with that, all the data from that application, from that point, which is application consistent, comes to the data node.
So that's what I mentioned. That was
Yeah,
the
yeah.
question. At that point in time, we get all that down to the data plane.
But that's not zero impact backup then, because you freeze your application.
Well,
No, that is just a momentary. So I'm going to talk in detail about it, but freeze the application. The application is not frozen till the time the snapshot is taken, till the time data is moved to the data node, or till the time it is backed up. It is just for a moment to mark the epoch, or we just insert a marker. So whenever application is doing I/O, it is doing I/O in a sequence, right? So let's say I've got an application request that okay, this is something which I need to take the snapshot of. I just make an I/O. That I/O says that okay, this is the snapshot I/O, and we allow application to kind of continue to do I/O after that. When the snapshot is kept, we create the version by reading that snapshot marker.
the only thing we have to do is to put an epoch. That's all.
Sorry?
You don't have to wait for all the snapshots to be taken or copied down. Just put an epoch.
So
the deltas. So we know what deltas are before and after.
Okay.
That's all.
it is
The
just
thing is
another
that
I/O.
We will do this in the next release across all the VMs you have in a consistency group. Because it's just that. Put an epoch.
Consider it just another I/O of application on that particular volume, right? So once we get the data on the data plane, we create a version for that particular volume and we update the Cinder DB so that next time whenever restore is invoked for that volume, we restore from this newly created version. Now I'll go a little
ask you one question?
Yeah, sure.
You said that the VM location is also stored in the database. What happens if the VM is being vMotioned? How does it get updated in the database then?
Okay, so this database is not the HyperScale database. There is the MongoDB database which OpenStack uses. Now the OpenStack has the information, so you can run OpenStack Nova list, right? So which tells you that okay, these are the virtual machines, and this virtual machine is hosted currently on this node.
So
now,
it's the database of OpenStack.
Yes, it's
okay.
so. That's where Carlos mentioned that okay, it's not a product which is built and later integrated with the OpenStack. We have built it for OpenStack. All that information which is there in OpenStack we understand, and we make OpenStack understand what we are doing.
Yes, I understand.
Right? So another example. So one more example I would like to state, which we discussed earlier, is that okay, let's say if your VM is running on compute 1, right, and something happens in the storage of that data node. If that dies, so your VM continues to run over there, but we will service IO from some other node. In that case also, we will let OpenStack know that okay, where is the disk, where is the data.
Yeah.
Okay, going one level deeper into it. So this is API first architecture, microservices, everything is built on API. So we have built all the backup APIs. You talk about from discover perspective, you talk about from snapshot or backup or restore perspective. For everything we have HyperScale APIs available. Now to make this HyperScale API available, these HyperScale APIs to service the request talks to 3 components. The component which we have on the HyperScale Nova, HyperScale compute plane, which is actually your Nova node where the virtual machines are running. We have our services running on the data plane, and we have a HyperScale controller. On the Nova node, what we have is we have actual Nova and KVM services running, and for every virtual machine, we do have a libvirt driver which talks to the KVM and then which understands that okay, this is the application which is writing and which is not writing. On the data plane, we have Cinder driver, plus there are 2 HyperScale daemons which we have. HyperScale control daemon which addresses or services the control command like snapshot, restore, create the versions and all those things. Backup daemon is the daemon which talks to the backup application. So let's say I am writing a third-party application and I want to make some calls that okay, take a snapshot, give me the data, and I have the data, restore this. So actual data transfer is governed by the backup daemon, and the control daemon takes care of the control commands like snapshot and version management. We have our data node storage layer which keeps the history of version management. So we discussed about creating point-in-time copies after every 15 minutes. Now consider a case that your OpenStack environment is running, let's say, for 2 years time. So are we going to have those many copies? No. So this DNSL is kind of going to keep latest 2 copies, and this is policy driven. You can define how many copies you want to have, right? So this is, and we interact with directly storage.
Is there a maximum number of copies you can store?
You can define as many as you want.
Okay, so there's no maximum. There
is no maximum. So the architecture is quite flexible, and apart from those 2 automated snapshot, whatever snapshot user have taken, all those snapshot will keep. Will never kind of garbage collect those things. HyperScale controller is a component which orchestrates all this flow in terms of when to talk to Nova, when to talk to Cinder, when to initiate the EDS and taking data from compute to HyperScale API just talks to these components. It talks to OpenStack Nova service, talks to Cinder driver, talks to controller, and the daemons to service the request. So this is a nutshell in terms of how do we service it. Okay, now I'll jump into the application consistent demo. Okay, before this I'd like to give you one background. I'll just pause the video for a second. So in this environment, what we have is we have a Windows instance, Windows virtual machine which is running in OpenStack environment, and that virtual machine has Microsoft SQL Server running, right? So we'll see how it is. So for any virtual machine which you want to have as an application consistent backup or application consistent snapshot, you need to talk to the Chemo agent. So first thing what we have to do is like we have to modify the image to have Chemo driver property, and that Chemo driver property needs to be set as yes. So means the KVM running knows that okay, this particular virtual machine has a Chemo guest agent installed. In this case, this is our virtual machine which is launched with that image. Now we are going to install a Chemo guest agent inside it. Once the Chemo guest agent is installed, HyperScale plus Nova and the guest machine all are connected. As soon as now in this case we are seeing that okay, this is a Windows machine, so Windows Service Manager is showing. we are using HammerDB here to generate the SQL I/O workload. So HammerDB is just an application which can simulate the TPCC SQL workload. What we are going to do is like we are going to create a job, just provide SQL Server credentials into it so that it can talk to the SQL Server. We'll define that okay, we have 20 databases which we are operating on and 20 users simultaneously working on those databases. What we are going to do is we are going to run this script for 30 minutes. Once the job is created in HammerDB, we are just going to run the HammerDB, and you will see that okay, all the users, there are 20 users which we have created, are using those 20 databases randomly. And during this time, we go to the net backup. Because it is a net backup, you can invoke the API. We just initiate the backup. Once the backup is initiated, you will see that guest, which is the Windows machine, and the Microsoft SQL Server application, it knows that okay, backup is running, and it identifies that okay, backup request has come. So I don't know how many of you know about VSS writers. So yeah, so SQL VSS writer, it talks to the, it tells the SQL VSS writer to freeze the application for a moment. We take the snapshot copy and then we insert that marker, and that is how the snapshot is taken. Once the backup is complete, you will see that okay, in activity monitor of the net backup, that okay, backup is taken, it is complete. You will also see the task completed in HyperScale pen. Once the backup is there, you can consistently restore it. So we have just created this backup. What we are going to do is we are going to restore it. We'll go into the backup. This is our backup which we have created. Using one-click restore, we are going to spawn up another VM with this data. Okay? Now remember, we have taken a snapshot of a VM which was running Microsoft SQL Server with 20 users simultaneously putting load on it. When we have restored, your SQL Management Studio is able to recognize the database without any problem. So this is the application consistent backup. Yeah. With this we can. So there is.
Before you dive on,
Yeah.
how many of you use Qumio guest agent? Not many. You one? Okay, so fair enough. Okay. Do you think it's is it an overhead to use Qumio guest agent?
I'm not so impressed with it, that's why I don't know.
Okay.
Yeah.
But maybe now.
So in the morning we had 3 people in the panel, right? So we had Worksport.
3 minutes, so let's go through this and make sure we can get questions.
Yeah, so we can take the question. This is just a slide in terms of how our backup APIs are exposed. So what we have is like OpenStack environment is a secure environment. When we talk to this OpenStack environment using a backup application, you do not want that backup application to be sitting in the same. It will be sitting outside in some public network so that if the whole site goes down, your data is still protected. So this channel talking from backup host to the HyperScale data node is secured with HTTPS protocol. All the APIs are HTTPS REST APIs. So you talk about backup APIs or you talk about data transfer APIs, they goes via HTTPS channel. While the HyperScale data node, the information it needs from the OpenStack, they talk over HTTP REST-based API. So if you are sitting inside the OpenStack environment, you can either use HTTP APIs. If you are sitting outside the environment, you use the secure HTTPS API so that your data is also protected when it is transferring over the channel. Yeah, this is pretty much which I had.
So what question do you have, and of course, what do you think?
How about if your data is encrypted? Is there also something about encryption with that or not?
So we can encrypt data with.
So NetBackup will encrypt the data and it stores it once it's read it from the data node. And obviously, you just talked about the capability to protect it using HTTPS. Now, you want to encrypt that communication path as well. That's network layer level encryption.
Yeah, so this is what HTTPS will do.
No, but that's our data transfer.
Yes.
But the actual backup host that.
Correct. So that is where the net backup software.
Automatically encrypted. So NetBackup is a one of the large enterprise backup solutions in the marketplace. It has all of the backup functionality and features that you could potentially want.
In order, like if the backup host gets compromised, then they have your data.
But that's encrypted.
Yeah.
It's encrypted.
What type of encryption is it?
I don't know offhand. As a matter of fact, there are multiple options for you.
And you define that again in the policy when you create that policy. one of the properties is how do you want to encrypt your data. So you just make one click and select that.
But it also depends on how the data is stored, right? So when you store it in a deduplicated pool, for instance. Each chunk of data will be encrypted individually with its own hash and its own CFC algorithm. But you can also store it on tape. Maybe not a lot of people still use tape, but some people do. And that could have an encryption key tied to it as well, tied to the hardware of the tape device.
The data plane, what kind of storage is it?
Whatever you
It's
want.
commodity hardware.
If it's network attached storage or not?
No, it's commodity x86 boxes with local storage.
Mhm.
You could potentially attach other storage to those x86 boxes, but by default, we'd recommend, you know, a 3U box or a 4U box with a little bit of flash and lots of spinning disks. And that's always going to be cheaper than an array from an vendor.
Yeah, but by the way, if you have in your lab an array, a SAN environment which you are using, you can still use that storage with the data plane.
Yeah.
So we
Reuse the
But
existing
if
storage
you
you have.
have the 3U nodes or something like that in front of it, then you can use your backend
Yep.
storage or not.
Absolutely.
Agnostic to node.
Hmm?
it's a software only solution.
We're going to be in the boat, so
Yeah, please. Thank you.